So in this picture we have two functions. F of x is 12 minus 3x squared. You can see that because it's x squared, it's a quadratic function which has the shape of a parabola. Because the x squared term is negative, it's an inverted parabola. Now the other function, g of x, is also a quadratic function. So it's in the shape of a parabola, and because the x squared term is positive, we see we have an upright parabola. So we want to get the area of the region enclosed by the curve y equals f of x and the x-axis. So we want this green shaded region. So we can see that the function is positive for all x over this interval. So we want to find the lower and upper limits for our definite integral. Well, the y-coordinate of this point is going to be 0 because it's a point on the x-axis. So as we saw before, to find out where the graph cuts the x-axis, we set y equal to 0. So our function is 12 minus 3x squared. And we want to find the value of x that makes it 0. So we set this equal to 0. So this is the output of the function. F of x is 0, or the y value. Okay, so this is straightforward. Very easy quadratic equation this, because there's no x term. We just isolate the x squared term. And we get x squared equals plus 4. So we see there are two solutions. We take the positive or negative square root of 4. We get plus 2 or minus 2. So clearly this is the point with coordinates minus 2, 0. And this point here has coordinates plus 2, 0. So to get our area, we integrate our function, which is 12 minus 3x squared dx from minus 2 to plus 2. Okay, we don't have any need to worry about whether the definite integral is positive or not, because the curve is entirely above the x-axis for x ranging from minus 2 to plus 2. So this will come out to be positive. Okay, if we integrate 12 with respect to x, we get 12x. Integrating minus 3x squared with respect to x will give us minus, when we add 1 to the power of x, we get x cubed. And then we have 3 divided by 3, which is minus 1. So we get 12x minus x cubed. And we apply our limits of integration, minus 2 to plus 2. So we plug the upper limit in, which is plus 2. Then we put a minus sign, and we write this out replacing x with minus 2. So here we get 24 minus 8, which is 16, and in here we have minus 24, and then we have minus 8, so it's minus 24 plus 8. That's minus 16. So we get 16 plus 16, which is 32. Now we could have exploited a bit of symmetry to calculate this area. By symmetry, the area under the graph of f of x from 0 to 2 is half the area under the graph from minus 2 to 2. So we could have just integrated from 0 to 2. And if we did that, well, things would be maybe slightly easier with the limits. You know, we would have 12x minus x cubed from 0 to 2. If we plug the upper limit 2 in, we get 16 as we saw before, but if we plug 0 in, well, we get 16 minus 0, which is 16. Okay, so 16 would be this area here, and of course we just multiply 16 by 2 to get 32. Now in part 2 we want to show the region enclosed by the two curves is half the area, well, half the green area. So this is what we're after, this purple area. We want to prove that this purple area is half the green area. Now, to get the purple area, we will start by getting the area under the graph of g of x from this point here to this point here. This area I will shade in blue. So the lower limit is the x value of this point here, and the upper limit for the blue area is the x value of this point. Now, because both curves are symmetrical about the y-axis, we could just integrate from 0 to this point here. integrate, that is, integrate g of x from 0 to this point, and then just double the answer to get the total blue area. Of course, we have to find these limits. So if this is x, then we notice that both functions have the same y value. In other words, the value of f at x will equal the value of g at x. So we put f of x, which is 12 minus 3x squared, equal to g of x, which is 9x squared. If we solve this equation, we will find the value, well, two values actually, of x that make the functions equal to each other. Okay, so they're both equal to the same value at this point, and of course at this other point. Now by symmetry you will see that there's only a sign difference between these two values of x. Now this is a very easy quadratic equation to solve. There's no x term. Isolate x squared, bring the number over, divide and get the square root. So there are two answers. X is the square root of 1, which is plus 1 or minus 1. So this value must be plus 1. The other value is minus 1. So we want to integrate g of x, which is 9x squared, from 0 to 1. So we add 1 onto 2 to get 3, we divide 9 by 3 to get 3. We plug the upper limit in, we get 3 times 1 cubed, well that's 3, and then minus sign, plug in 0 for x, well that's just going to give us 3 minus 0, which is 3. So I'll just work with the part of the graphs that's to the right of the y-axis. So this region here is 3. Of course the other region is 3 as well. Now if you had integrated from minus 1 to plus 1, you get 3 when you plug in the upper limit, then you have a minus sign. If you plugged in the lower limit minus 1, you would get 3 times minus 1 cubed. Well that's 3 times minus 1, which is minus 3. You'd end up getting plus 6. Now to get the purple area, we are going to get the area under the graph of f of x from 0 to 1. So I'll do that in yellow. This area here. So we're going to integrate from 0 to 1 f of x, which is 12 minus 3x squared dx. Now we've already done that integral. That's 12x minus x cubed, but this time the limits are from 0 to 1. So if we plug 1 in here, we get 12 minus 1 is 11, and then we have a minus sign. If we plug 0 in, we get 0, so we have 11 minus 0, which is 11. So to get this purplish area here, we take 11 and simply subtract 3 to get 8. So this purple region here is 8 square units. So by symmetry, this region next to it is also 8 square units. So the total purple area is 8 plus 8, which is 16. And you can clearly see that 16 is half the green area, half of 32.